In this video, we'll move into section 23, where we will discuss the technique that is known as completing the square. Now, what I want to point out here, everybody, this section has a few very interesting and important components, especially for a lot of the students who are moving on to pre-calculus. But I'm going to be honest with you, I don't put the homework up for this. I don't put the homework solutions because I don't ask any direct questions that come from this section. So this is more just a good information for you as a lot of you go forward. And before we get into completing the square, our book actually starts off by introducing what they call the square root property. This is definitely interesting because what we have done up to this point, we've always pointed out that if we have simple equations, which meant x to the first power only, we could always isolate that x and solve in that sense. X is to one side, everything else to the other. But if we saw higher powers of x, that's where we said, harder equation, set it equal to 0, we need to factor. Well, we can do a little better than that. If I had something like x squared equals 25, because there's only one x, I can isolate it. It's actually already isolated. And just like we've seen, we use inverses to solve. How do I undo this square? I will undo the square with a square root. The square root and the square will cancel. That'll get me down to x. Whatever I do to one side, I have to do that to the other side as well. But this is where the square root property kicks in. Because a lot of us do this and they go, oh, okay, nice. Square root of 25. That's a clean 5, and they think they're done. And even if they check, 5 squared is 25, it works. But you have to realize there's also a second solution here. You also get a negative 5, because negative 5 times negative 5 is also positive 25. So the point, the square root property tells us that if I have x squared equal to a, when I solve, this action of taking a square root across the equation, it comes with a small penalty. That when you take the square root of the other side, you also get a plus or minus out in front. So, we can see how that worked here. Just took the square root, and instead of seeing the two answers separate like that, can almost put them together with that notation. And we just need to recognize that as two answers, positive 5 and separately the negative 5. Then they point out how you could do this on even more complicated situations. What if it was x minus 3 squared equals 10? There's still only one x here. Now, most of our instincts to this point would be like, it's messy. I got to FOIL all this out, x minus 3 times x minus 3. Then I'll have a lot of x terms. I'll have to bring this 10 to the other side, get it set equal to 0. But what we can do, if we look at it carefully, we could realize, hey, there's still only one x here, so we could still try and isolate it. The outermost piece is the square. I'll get rid of that with the square root. So I'll bring the square root on both sides. On the left side, it cancels here and here. So I wouldn't just get x, I would have the quantity x minus 3 come down. On the other side, well, if this was a perfect square, or if I could reduce it, I would. But unfortunately, 10, nothing good comes out of that. But I am going to still need that extra plus minus. Finish solving for x here. I'll do a plus 3 on both sides. Here it cancels. There's my x. I could write plus or minus rad 10 plus 3, but most people would put the 3 in the front and have 3 plus or minus rad 10. Two answers. That's 3 plus rad 10 and 3 minus rad 10, just like this was two answers up here. So that's neat. And now that finally gets us to this idea of completing the square. Completing the square, the idea of that is to take a complicated equation, a complicated expression, I should say, and to break it into something like this. So if I had x squared plus 6x equals 3. If I just take my normal instincts, I do the -3 on both sides, set it equal to 0, but I can try something like this, but in order to do this, I need to bring these together. I can't have an x squared and a separate x. I need to be able to put this together in some form as some perfect factor squared. That's what completing the square is about. Now, how do we do this? 3 steps. First step, the leading term has to be a 1. If it's not a 1, we'd start by factoring that out. Once I have that, then I come to this term, and I cut it in half. So leading term has to be 1. Then I cut my middle term in half. 6 divided by 2 would give me a 3. Whatever I get here, I bring that in to my expression or my equation, and I square it. The value here squared is what I bring back to my expression. Now, if I don't have a full equation, I'd have to keep this balanced. I just introduced a 3 squared or a 9 that wasn't there. So in order to keep everything balanced, I'd balance that with a -9. 9 minus 9 takes me back to 0. I'm right back to where I was. But if we do have the equation, instead of balancing it on one side, whatever I do to one side, I'll also do to the other. Now this has become x squared plus 6x plus 9, and on the other side, I've got a 12. There is a shortcut here, but for right now, I want us to take the long approach. How does this side factor? I see a nice trinomial. I'm going to go to the grouping number. 1 times 9 is 9. What multiplies to 9 and adds to 6, well, that'll be 3 and 3. So this will become x squared plus 3x plus 3x plus 9, and I still have the 12 on the other side. Here, well, factoring, and x comes out, x plus 3 is left. Here a 3 comes out, x plus 3 is left. So x plus 3 is the common factor coming out, and coincidentally, and x plus 3 is what's left behind. Instead of leaving it as x plus 3 times x plus 3, we'll make it x plus 3 squared, and it equals 12. It's not the easiest thing, and this is where, for a lot of us, at the end of this section, we're going to realize the quadratic formula comes out of all this work, and for a lot of people, that's the easiest way to do this. But all that work to take this equation and to make it look something more like this. So that now, how do I finish this problem? I'll get rid of the square with a square root on both sides. Here it cancels. X plus 3 comes down. Over here, I'm getting the plus or minus, but this time the radical 12, I could think of as 4 times 3, so I could simplify it, and I would get 2 radical 3. I'll subtract 3 from both sides. Left side cancels. I've got x. Right side, trying not to line these up. It's tempting, but don't actually combine these. I'm getting minus 3 plus or minus 2 radical 3. And once again, that is 2 separate solutions. Minus 3 plus 2 radical 3 and minus 3 minus 2 radical 3. So a lot of people look at that and it's, wow, that's quite a lot. So what I wanted to focus on was the idea of completing the square, and that when you do complete the square, come to the end here, what's so special about this factor? It's x plus the value we found here. So instead of factoring this in the long way, you could take advantage of a shortcut, just know that's going to become an x plus 3 times x plus 3, but we still have to solve the rest of the equation. And now let's look at another one. Now let's look at 2x squared plus 12x equals negative 13. When I described that completing the square process, we mentioned the first thing, the leading term has to have a 1. This does not have a 1. So what you would do, you would factor whatever that is out. I take a 2 out, now I've got a 1x squared. I still have to take out of the 2 out of this, that gives me a 6x. And now I'll leave some space inside the parentheses. Because now I'm going to go through that same process. I'm going to go to that middle term, cut it in half, I get a plus 3, square it, plus 3 squared is really a plus 9. But this time, the big difference, here I added the 9, over here, added the 9 on this side, added the 9 on that side, kept everything balanced. But this time, I didn't really add a 9. That 9 is in parentheses. I really added an 18. I really got a 2 plus 2 times 9. I've got an 18 on this side, 18 on this side to keep it balanced. 2 still out in front. This becomes quantity x plus 3 squared equals 5. Before I get rid of this with the square root, I'll divide both sides by 2. Now I'll do a square root of both sides. X plus 3 left on this side, plus or minus radical 5/2 over here. And then I'll subtract the 3, minus 3, plus or minus radical 5 over 2. So I'm not trying to make a huge deal out of this, everybody. This is what they show us in the book, that completing the square gives us another way to solve some of these harder equations. But as I just said a moment ago, the quadratic formula will also do that, and that is much more friendly. That's why I don't want to make too big of a deal of this section. The quadratic formula is way easier for so many students to use. So we'll get to that in just a moment. We'll introduce it here, but that's what section 24 is all about. So we'll get plenty of that. But again, just to finish, I just want to show one quick other aspect. Why do we care so much about completing the square? Well, not to jump too far ahead, but again, some of you are going to go to pre-calculus, and you'll eventually get to something like this. This is the standard equation for a circle who is centered at coordinates a comma b and has r, that's an r squared, has plane r as its radius. So if you have something like x squared minus 10x plus y squared plus 2y equals 20. That, if I work hard on it, I could turn this into this form. How am I going to do that? I'm going to do it by completing the square. I'm going to look up front here. I've got the leading 1. I cut this middle term in half. I get a minus 5. So I'm going to leave a little space here. And then similar for the next one. What am I adding here? I'm adding a minus 5 quantity squared. I'm getting an extra plus 25. So on this side, I'd also have a plus 25. And back here, this will factor into x minus 5 times x minus 5, or x minus 5 quantity squared. Over here, I'm sorry, folks, I wanted this to be a 10, not a 20. A 10, because as I go over here, cut this middle term in half, I get 1, positive 1. Positive 1 squared is positive 1. I added that to the left side. I'll add it to the right to be balanced. But now that y squared plus 2y plus 1, what we're doing here, we're finding the magic number so that this expression, not only it factors, but it factors as a perfect square. And just as we saw the minus 5 here, this became x minus 5 squared. Well, here the plus 1, this became y plus 1 squared. Combine the stuff on the other side. I get a 36. And now going back to this original form, I would notice that A is 5, B is -1. So this would have a center 5 comma -1. And if R squared is 36, R would just be 6. Technically, you're applying that square root property. You get plus or minus 6, but the concept of radius is a concept of distance. So that's where, just context, we'd only keep the positive 6. Center and radius, if we were going to graph this circle, we would need that information. And again, folks, I don't want to go crazy here. I've already done more than I intended. Just to point out there's good information here, and especially those who go forward to pre-calc, you'll see more of this, so to at least have a nice introduction here. But all of this eventually leads me to this concept. If I have this standard quadratic equation, a quadratic, this only works for degree 2 polynomials. If I have this quadratic equation, I will set it equal, I'll make sure it's set equal to 0. That's where it's in its standard form. And if we have that standard form, we will know that the solutions to this equation will be this: -b plus or minus square root b squared minus 4ac all over 2a. Where did that formula come from? Somebody actually did the completing the square idea generically, and that's what we end up with. So we don't have to do that. Now what we'll see in section 24, I'll reintroduce this fresh, and when we do, we'll see how to use it and how that can help us with a lot of our more complicated equations.